Let it be me. Let it be me. I need somebody. Sawyer. Hi, Sawyer. Okay, what I need as you're coming in, what I need from you is I need you to open up your review. It was homework number, homework for 11:10. Homework 11:10. Open it up. We're going to go through our answers for that. Oh, Olivia. Kaylee B. Gabby Campany. Jaden Ramos. Good morning, guys. I'm going to come around in a second. I just want to get everybody in first. And then while we're waiting, if you wouldn't mind opening up that homework from 11:10. Homework 11:10, please. Okay, I'm going to get started right away, actually, because I want to make sure that we get through everything. Let me just come around and we're going to look at the review. Actually, before I start to share my screen, I'm going to take some of these answers off here because Miss Germaine. Hey, give me 30 seconds. Okay, while we're waiting, if you wouldn't mind opening up the review homework from the review packet that was given out to you on 11:10. So the homework, the review that was given out to you on 11:10. It was your homework assignment. Okay, give me like 30 more seconds. Sorry, guys. Okay. Okay, here we go. Here we are. So I'm going to share my screen and we're going to get started. Let's take a look. Jonah is here. Woohoo, party, party. Jonah is here. Let me pull the participants over here. Let me pull the chat over here as well. And then we will be 100% ready to go. So we're opening up the review. It was given to you under the assignment of homework 11:10. And let's get started. Okay. So we're looking at and we're highlighting all of the true statements here. So when we're looking at, if you have questions as we're going, throw them in the chat for me and I can answer them as we're going, okay? So highlight all the true statements. Dilations always increase the length of a line segment. That important piece here is always. That's a really important modifier that tells us 100% of the time. So did you guys highlight this one, yes or no? Throw it in the chat. Nice job, Sawyer. Nice job, Kyle. Nice job, Jaden. Nice job, Isabella. Fantastic. We did not highlight this one because of this word always. Sometimes when we dilate, it decreases our side length. So if this had been modified or changed to the word sometimes, then I might have highlighted it. Then I would have highlighted it. But because it used that word always, I couldn't highlight it because every single time it does not increase. Sometimes it decreases or it stays the same. So now dilations take perpendicular lines to perpendicular lines. If we think back to that idea of perpendicular lines, those are two lines that are never, ever, ever going to touch. If you have two perpendicular lines and say you dilate them by a scale factor of 1/2, they are still never, ever going to touch. So this one you would definitely want to highlight because it is a true statement. If you have two lines that are never, ever, ever going to touch and you dilate them, then they're still never, ever going to touch. They might be a little bit closer, like they are here, like these are a little bit closer, but they're still never going to touch. Okay? So now, dilations of an angle are congruent to the original angle. Did you guys highlight this one, yes or no? Angles are congruent after a dilation.
I highlighted it, so yes.
Yes, nice job. Was that Olivia, right?
Yes.
Nice job, Olivia. We did highlight this one. Perfect. Because when we dilate a shape, my angle measures stay the same. The side lengths are the bits that change. Okay? So now, then D sort of comes in and it says now dilations increase the measure of an angle. Did you guys highlight this one?
No.
Nice job, Olivia. No, we didn't highlight this one because remember, we just said this like 30 seconds ago. No, angle measures always, every single time, 100% of the time, stay the same. So you're not going to highlight that one right there. Very good. So now, dilations of a triangle are always congruent to the original triangle. Once again, this word always is the most important piece here. This word always means 100% of the time, right? So are dilations always congruent? Yes or no? Throw it in the chat, guys. What did you think, Bridget? Very good. It's this word congruent too, Carter. Congruent means same size, same shape. So congruent means it's exactly the same. It's a direct copy. But when we dilate, sometimes my shape gets a little bit smaller or a little bit bigger. So this one says that every single time, 100% of the time, it's exactly the same shape like these two here. But it's not always 100% of the time. So we're not going to be able to highlight this one because of this word always. If you had put sometimes in here, once again, I would highlight that one then because sometimes it does stay the same, but most of the time it either gets bigger or smaller. So this one, E is not, you're not able to highlight E because it's not always true. Okay. Last one, a dilation of a triangle are similar to the original. What did we think about this one? Nice job, Swin. Nice job. Fantastic. Was that Annie? Or was that Avery?
Avery.
Avery, nice job. Very good. We would say that this one would be highlighted because similar, if we remember, similar means same shape, different size. So it has to be, dilations have to be similar, same shape, but different size, okay? So we highlighted, in the end, we highlighted B, C, and F. I would make sure this evening that you look over these 6 statements again and look through the ones that we actually highlighted at the end because they might be, you might be faced with similar questions and statements tomorrow, okay? Let's take a look at this next one here. We're looking at these two quadrilaterals that are similar. Okay, two quadrilaterals that are similar to one another, corresponding sides. Which one corresponds with AB on the new one? Nice job, Jaden. Right in the game, my friend. HG, or you could have written it GH. Okay? Those two mean the same thing. Now, Sawyer, throw in the chat. Which one is corresponding to BC on that larger one? Nice job, Sawyer. GF, very good. You could say GF or you could say FG. Both of those mean the same line. Now, let's look at CD. Can I have Annie throw in the chat? Which one corresponds with CD on the new one? Nice job, Annie. FE, very good. FE. You could also have written it as EF. Nice job. Last one here. Billy, help me out. Which one corresponds? Ooh, I just sort of gave you the answer. Which one corresponds with AD on the new one? Billy, help me out. What do you think, Billy? Billy's in here, right? I think he is. No, maybe not. Oh, yeah, he's here. Nice job. So, Billy, I need you paying close attention for this. We're looking at side DA. Which one corresponds on the larger one? Very good. EH. Nice job. EH. Or you could have written it HE. Very good. Nice job, Billy. Thank you. Make sure you're paying close attention as we move forward. This is important stuff, okay? We're looking at angle A here. Which one corresponds with A on that new shape? What do we think? Nice job, Gabby Campany. Angle H. Fantastic, Lady Jane. Angle H. Very good. Ooh. Miss Jermaine, dropping stuff. Okay, we're looking at angle B now. Angle B, which one corresponds with angle B on that larger shape? Nice job, Avery. Angle G. Fantastic. Now let's look at angle C. Jonah, help me out. Which one corresponds or matches up with angle C, Jonah? Angle C, which one on this new figure here corresponds or matches up with angle C? Nice. Okay, let's take a look. Angle E corresponds with angle D, Jonah, but we're looking at C. So C corresponds, just like Avery said, with angle F. Very good. And then Jonah, like Jonah said, he said D corresponds with E. Very good. Very good job, guys. Now, let's take a look at the estimated scale factor. What did you estimate here for our scale factor? Nice job, Gabby. Gabby said 2. Okay, what else could we have said? Avery said 2, Bridget said 2, nice job. What if I said 1.5? Would that work? Why not, Bridget?
Because you're going from smaller to bigger, not bigger to smaller. So it can't be less than 1.
But 1.5 is larger than 1. It's 1.5.
Then yes, it could work.
Very good. You could say 1.5. You could say 1.5. You could say 1.1. You could say 3, but I wouldn't really take anything bigger than 3 because 3 is kind of big. I mean, because it's not getting that much bigger. If you look at like the grid lines on this paper, we're going from like a side length of 2 to a side length of 3. So it wouldn't, I mean, technically it wouldn't really be 2, but I would still take 2 because it's bigger. Okay, nice job. Let's take a look at the next piece here. Select all of the lines that have a slope of 1/2. So when you looked at this image here, and it has a rise and a run on this slope triangle, what did we think the slope was for this first? It had a rise of how much for A? It had a rise of 2, very good. And a run of, just like Sawyer said, 4. Very good, nice job. Everybody who just helped out with that. So if I were to write that as a fraction, it would be equal to what fraction, guys? 2/4, which is equal to what fraction? 1/2, very good. So you want to make sure that when you have a fraction like 2/4 or like 3/6, you simplify your fraction. So what did you put for in this box down below? Did you check the yes or did you check the no that it has a slope of 1/2? Nice job. We said yes, it does. Very good, because it simplifies to 1/2. 4/2 simplifies to 1/2. Very good. Or 2/4 simplifies to 1/2. Sorry, guys. Now let's take a look at B. Nice job, Olivia. Being very reflective on your thinking. Very good. Now B has a rise of 4 and a run of 2. So my slope would be equal to what? Slope would be equal to what fraction? Throw it in the chat for me, guys. Nice job. It would be equal to 4/2 this time. So is that equal to 1/2?
Yes.
It simplifies.
Sorry, I meant no.
2/1, which equals 2. It's not going to be 1/2. Don't get yourself tricked by simplifying that fraction. Very good. This guy would have a no because it has a slope of 2. Let's take a look at the third one now. C. C doesn't have the slope triangle drawn in for you, but it has the points drawn on the line. So let's take a look at it, okay? So if I draw my slope triangle in, it has a rise of 1 and a run of 2. So that would have a slope of what number here? Nice job, Jonah. Nice job, Bridget. Nice job, Avery. Nice job, Bridget. A slope of 1/2. Very good. So what are we going to check on this box here? Is this slope equal to 1/2? Nice job, my friends. Now let's take a look at D. D's a little bit not too bad, but it might be a little bit tricky for some people. No. Okay, here we go. Here we go. Sorry. I got caught up. I don't know what happened. Let's take a look. D has a rise of 1, but a run this time of 3. So what would this D's fraction be for a slope? Nice job, Jaden. Nice job, Sawyer. Nice job, Avery. It would have a slope of 1/3. So this one, are you going to check no or yes? Nice job, Jaden. It would have no. A slope is not equal to 1/2. Very good. I have to do the same thing I did with 4 here. I have to draw my slope triangle in for this guy here. It has a rise of 4, a run of 3, so it has a slope of what fraction? Nice job, Jaden. Nice job, Sawyer. Nice job, Avery. It has a slope of 4/3. thirds. So does this one have a slope of 1/2? No, very good. Nice job, guys. Make sure you have these corrected if you didn't have the right one in there. Okay, let's scroll on down to page number 3. Okay, and we're looking at some polygons here. Okay, so we have some polygons and we're deciding, are they similar to polygon A? So I want you to tell me in the chat, did you highlight polygon B saying that it was similar to A? Very good. So Kyle, why don't you unmute yourself and tell me, why did you highlight polygon B?
Oh, okay, big fat oops. I chose B because it is the same thing as A, but bigger.
But bigger, good.
Same, but still,
And we had a multiply.
bigger.
Oh, sorry. Very good.
Myself now.
Who's that? Was that you? Okay, so we had to take these side lengths and multiply them each by the number 2. So this one went from 3 to 6. This one went from 4 to 8. Multiply by 2, multiply by 2. Very good. Now, what about C? Did you highlight C, yes or no? Throw it in the chat. Okay, I'm going to call on Gabby Campany because I have not heard from her in a while. Gabby, why don't you unmute and tell us, why did you not pick C?
I didn't pick C just because I didn't like, it wasn't like dilated by anything, so I wouldn't think that they were related.
Okay, good reason, Gabby. She said that it didn't look like it was dilated by anything. Very good. But also, if we take a closer look and we actually count the distances here, we can say that if you can dilate by a scale factor of 1 to get like a copy, but this one isn't a perfect copy from A to C. It has a height of 3, but if you look at the length, this one A has a length of 4, and this copy has a length of 5. So you can make a copy from, like, you can do a scale factor of 1 and make a copy, but this one isn't a perfect copy because the length, the top length, is not the same as the top length on A. Do you guys see that? So I like that reason, Gabby, but we just want to be a little bit more precise by saying it's not an exact copy, right? Good. Now, let's look at D. Keeping in mind that we can make an exact copy. What do we think about D? Did you guys highlight D? Okay, so I see Kyle and Sawyer both said yes, and so did Kaylee, and so did Ethan. Good. Like I said before, you can take a shape and dilate it by a scale factor of 1. I don't know. Can you guys see my finger? I don't know. A scale factor of 1, and it would make an exact copy. But this one wasn't because the length was a little bit longer. But if you compare these side lengths here, we have a height of 5, and this one has a height of 3, sorry, and this one has a length of 3. And then it has an opposite length of 1, 2, 3, 4. This one has an opposite length of 1, 2, 3, 4. So this is an exact copy from A to D. So we can, nice job, Avery, we can highlight D because it is a similar polygon. Because if we remember back to that like second or third lesson we did this unit, we said similar shapes can be congruent, and these two are congruent. Okay? Now let's look at E. What did we think about E? Did you highlight E? Let's see. Isabella, what did you put here? Throw it in the chat. Did you highlight this one? Yes or no? Okay. So let's look at these side lengths now. We had a longer length. Nice job, Kaylee B. Yes, Kaylee B. We had a long side length here. We had this top side length of 4. This one has a top side length of 2. So it got smaller by half. Then this had a tall, like the height of this was 3, and this height was 1.5, which this is half as tall as this one. So if we multiply by 1/2, it's going to get us this shape E. So is that one similar? Yes. So this one we actually would want to highlight because it is similar. The reason that it's similar is that we multiply our side lengths by half and we get the side lengths over here. Because half of 4 is 2, half of 3 is 1.5. Kaylee B, that's the perfect way of saying it. E is half the size of the original figure. Awesome, awesome job, Kaylee B. Rock star moment right now. Awesome. And then what about F? Did we think that F was a similar figure to A? No. Awesome job, guys. No, because it's not the same shape. No, don't do that to yourself. That's not right. And then for this bottom section here, it says for one that you said was similar, describe the sequence of transformations that takes A to the shape you selected. So for example, if you selected B, you could say the sequence of transformations that would take you there would be a dilation by a scale factor of 2. I don't know why I'm yelling. Got to get rid of that cap locks. And so it's a oh, that's not what I wanted. So we dilate it by a scale factor of 2. So then it would take us here. And then we would have to translate it 1, 2, 3, 4, 5, 6 units to the right. Translate 6 units right. Okay. You could have picked D and you could have said rotate it 90 degrees clockwise, translate it 3 units right, and then 5 units down. You could have chosen E and said translate it 1, 2, 3, 4, 5, 6, 7, 8 units down, dilate by a scale factor of 1/2, and then translate it 1, 2, 3, 4, 5, 6, 7, 8 units to the right. Does everyone see how I did that? I went a little bit fast, but you had 3 options here. I just wrote out B. Okay. You want to make sure when you're doing this one, I'm actually going to put some additional explanations here. And I'm going to say, please use vocabulary, numbers, and directions so that people remember that they need to tell me everything when they're talking about that sequence of transformations. Okay. So now when we're looking from triangle ABC to DEF, we know they're similar. We need to find the side length of segment BC and AC. So if we look from this ABC to EFD, well, DEF, Mr. Rain, we know it's going to have a scale factor of 2. So to go, if I'm going from small to big, I multiply by 2. So if I'm going from big to small, I'm going to divide by 2. BC is equal to 3 units. And AC, half of 1 is 1/2 units. Let me go here, enter down, and I'm going to go 1/2 unit. Okay. Now this one, I talked to my boss and I got this one actually made to be a little bit easier. So what you're not actually going to see, you see how like this isn't on a grid here and that made it hard. I helped you guys out. we're going to actually put this line is actually going to be on a grid. So it's going to make it so much easier, and the slope triangle is going to be drawn on there for you. All you're going to need to do is calculate your slope, which is your rise over your run, and then you're going to need to find the missing pieces of each of these coordinates. So the rise and the slope of this guy here was, let me just get this guy up real quick, 8/2, because, or no, 8/4, I'm sorry, 8/4, because we rose it. The change in the y's was 8. The change in the x's was 6 minus 2, which was 4. So 8/4, which is equal to the number 2. Okay, when we wanted to find the value of A, if we go over 2, and then we would multiply, we would add 1, 2, 3 to this. So this would have, A would have a value of 5, and B would have a value of, nice job, Avery, 6. Very good, nice job. And I love that you were able to find that without the grids. Awesome, awesome job, Avery. Nice job to everybody, actually. Nice job. Wonderful. Last piece we're going to look at here, okay? So this one is, I didn't give you the full, I mean, you could have done this, but I purposefully only had you fill out this bit right here, because on the test tomorrow when we go to do this, I'm going to walk you through how to do it using GeoGebra, like how I'm going to expect you to do it. So you're going to need to be able to use these guys for tomorrow. So that's why I had you practice filling in these pieces right here. And then tomorrow we're going to be doing this actual drawing of the dilation together. I'm going to like walk you through how to do it. So nice job, Avery. She didn't forget about it. So that's why I'm not having you do this piece today, because we're going to walk through it tomorrow anyways. I just wanted you to focus on getting these dilation squares filled out correctly. So what I'm going to do is I'm going to scroll it down like a microcentimeter, and we're going to fill out some of these numbers in here. Oh, wrong one. Okay, so we have, here's a polygon. We're going to use the dilation boxes if needed to do this dilation here. So if we're looking at a center of dilation of A and a scale factor of 1/2, I need to count for these points here. I need to count my rise and my run away from A. Okay, so if I count my rise and my run from A, it's going to be 0, 0, and I'm going to multiply by my scale factor of 1/2. Okay, and then 0 times 1/2 is 0. My 0 times 0 is going to be 0. So the A prime is going to fall right on top of A. Okay, now we're looking at B. B has a rise of 0 because we're not going up or down. And it's going to have a run of 1, 2, 3, 4, 5 boxes. I'm going to multiply both of those by my scale factor of 1/2. And I'm going to get 0/2.5. You could also write it as 2 1/2. Both of those are correct. Okay. So then, very good. And then it would fall right here, B prime. The rise for C is 4. My run is 0, times it by my scale factor of 1/2. And it has a new distance of 2 and 0. C prime. Rise for D is 4 and 5, times it by my 1/2. And I'm going to have a new distance of 2 and 2.5. So I'm going to go down 2 over 2.5, name it D prime, connect to draw my new shape. Okay. Something similar is happening with, I'm going to leave that up for a moment just so you can get those dilation boxes filled in. Okay. Now, the last one we're going to look at has a scale factor of 1/3. Okay, So to draw the dilation of A, B, C, D using C as a center and a scale factor of 1/3. So you need to shift your center here. Now C is going to have a rise and a run of 0 times my 1/3. And it's going to have a new distance of C. So your C prime is going to fall on top of your C. So now if we're looking at A has a rise of 1, 2, 3, 4, 5, 6 boxes, a run of 0 times, right? So this is going to have a new distance of 2 and a new run of 0. So your A prime is going to fall here. B has a rise of 6 and a run of 9. And it's going to have a new rise of 2, a new run of 3. Starting at C, I'm going to go up to over 3, name it my C prime. And D has a rise of 0, a run of 9, multiplied by my 1/3 scale factor. And you get 0 and 3. Okay, so from C, you're going to go up 0, run it over 3, and it's going to be D prime. Okay? Similar, explain why A, B, C, D, or A, B, C, A prime, B prime, C prime, D prime, and A prime, prime, B prime, prime, C prime, prime, D prime, prime are similar to A, B, C, D. It means they are the same shape, different size. You might also want to say same angle measures and proportional size. Okay? I know that last bit I went a little bit fast, but we're going to be going through this. Nice job, Jaden. Together on the assessment. We're probably going to do this part on Wednesday, though. Okay? So, I know this was a lot. I know we did quite a bit, but awesome job, everybody. It starts at, yes, so you're 2 minutes late. I'm sorry. Tell her that I held you by accident. I'm sorry. I went over. That was me. Okay, guys? So you guys can hop out and have a great day. I'm going to see you tomorrow. Please make sure you let Miss Blanc know, okay? Bye, guys. I'll miss you. I'll see you tomorrow. Bye, guys. Sorry for holding you over. Sorry, I'm the worst. I know. Bye, guys. Bye, Kyle. I'm waving. You just can't see me.